Welcome to Study Loop.
In this podcast series is, firstly, we'll be looking at the internal energy of a system, which is the total energy possessed by individual molecules of that system. And then we will also be covering the specific internal energy, which is U hat. That is nothing but just the internal energy per unit mass of the system. So in the first part, what we have here is the following equation. U hat T equal to 25.96 T at 0.0213 T squared. Now we're plugging in our values for 0 degrees Celsius and for 100 degrees Celsius, and what we get is 0 joules per mole and 6046 joules per mole. So in the next part, it's not possible for us to actually determine the absolute value for the specific internal energy for any given process material. However, calculation of U bar corresponding to a specific change of state. For example, in the first part that we looked at, U 200 degrees Celsius is nothing but the change in the U bar temperature between 0 and 200 degrees Celsius. So in the third part here, what we have is the following equation. So we discussed B, now we're on to C. So what we have is delta U hat is U hat at 100 degrees, take away U hat at 0 degrees. That is 6046 joules per mole. Then what we do is multiply by 3 moles to get a value of 18,000 joules. And we're using the assumptions for the closed system. So onto the last part here, we're using the equation delta U bar, integrate within T1 and T2, CV dt. So what we do is we differentiate both sides and then we rearrange the equation to find CV, and CV is equal to du hat over dt. And what we can have is CV du hat dt with respect to V hat at constant volume. And what we find is that this value is equal to 18,000 joules.